guys, welcome back to my channel, and today we are going to learn about the operators in Java. But before learning about the operators in Java, I want to tell you something about like the binary number system because though I've already give the hint about like what binary number system is, but I want to elaborate it more because there are certain operators like bitwise operators which purely works on the binary number system, and also these are important because computers know binary number system, and we as humans we use a decimal number system. So let's first talk about the binary number system, then we'll come back to the operators itself. Okay, so computers, as a humans, we use decimal number system, but the computers use binary number system. So suppose this is binary number system, BINAR, right, binary number system, and we use decimal number system. Okay, so the difference is that like decimal number system means base 10, and binary number system means base 2. And what does it mean? Like in decimal number system, there are 10 values. There are 10 different values that we use to create all the numbers, like from 0 to 9, 0, 1, 2, up till like 8, 9, 10, and all. Like to create a 10, we are using these two values only. We have only the different values that are like from 0 to 9. In the similar way, in the binary number system, there are only two values. It could be either 0 or it could be 1. And how it works is something like that. Like there are circuits. If we pass the current in the circuit, so we can say like it is 1. That means circuit is on. We can say this is 1 and circuit is on if the current has been passed. But if the current is not being passed to the circuit, we'll say it's 0 or it's off. Right. So this is how like computer thinks. Like computer can know. So everything we create in binary number system works on this. Like either 0 or 1, either on or off. Like whether we are passing the current to the circuit or not. So that's why we also call it as base 2. So now let's take it. Suppose we have to write the binary equivalent of this 10. So how we will do that is, let's see. Okay, this is a 10, and then we have to write a binary equivalent of this 10. So what we'll do, we'll keep dividing this 10 by 2. So 5 times 2 is 10, and then the remainder is 0. We'll again divide it. 2 times 2 is 4, and then remainder is 1. We again divide it. 1 times 2 is 2, and then remainder is 0. Now we'll write from the bottom till the top, and then we'll get our like the remainders. We'll keep storing the remainders, and then we'll write these remainders in the fashion like from bottom to top, and then we'll get our like binary number of the decimal equivalent. So it will be like 1 0 1 0. In the similar way, we can do for like 9 and 8 and all. Let's do for 9. Let's say we have to calculate the binary equivalent of 9 itself. So we'll start dividing by 2. So 4 times 2 is 8, and then remainder is 1. Then again we'll do it for 2 times 2 is 4, remainder is 0. Then again we'll do like 1 times 2 is 2, and then remainder is also 0. Now we'll start from here when we read the 1 and right up till here. So it's gonna be like 1 0 0 1. Okay, my bad. It's a bit messy. Okay, 1 0 0 1. So this is binary equivalent of, we can say, the 9. In the similar way, we can write it for 8, like it's going to be 1 0 0 0, and then definitely you can calculate for other values as well. For 2, it's going to be like something 1 0, like 0 1 0, or we can put one more 0. And we can say for 1, it's going to be 0 0 0 1, and then for 0, it's going to be 0 0 0 and 0. Now this is how like we convert a binary, like the decimal number to the binary equivalent. Now, if we have to do it in the reverse order, suppose there is a binary number, let's say 1 0 1 1, and we have to convert this number into a binary number. Oh, sorry, decimal number. So how we calculate that is, first we'll take the numbers itself, because here to convert from decimal to binary. Okay, let me write it. From decimal to binary. Decimal to binary. And here we are doing from binary to decimal. Okay, so to convert the number from binary to decimal, we'll write the number itself, and then we'll start from very right, not from the left. Always remember this thing. We start from the right, and we start writing the powers of 2, like 2 raised to 0, 2 raised to 1, 2 raised to 2, and then 2 raised to 3. And after this, we'll multiply these values with the bits above, like if there is 1 or 0. So let's do this. So 2 raised 0 is 1, and 1 times 1 is 1. 2 raised 1 is 2, and 2 times 1 is 2. 2 raised 2 is 4, but 4 times 0 is 0. There should be 3, it should be 3. 2 raised 3 is 8, and then 8 times 1 is 8. Then after we get this, we'll sum up all these value to get our decimal equivalent. So it's gonna be 8 plus 2, 10 plus 1 is 11. So this is the like decimal 11, which is written like this. So we can put it 11. So in the similar way, we can do the other like problems. We can convert from binary to decimal and then back to binary or whatever we want. So now let me give you some questions. You can practice those questions and then let me know in your answers in the comments so that I can know you are getting the idea of like how to convert the number from binary to decimal and then back to binary or whatever. So you have to convert like number, let's say 13 base 10 to its binary equivalent. And then for the second question, you have to convert, let's say 11001, a binary number, to its base 10 equivalent, to decimal number. Okay, so this is the general idea of like how number system, like how binary and decimal work. Though there are more like octal and then hexadecimal numbers, but we are not talking about them right now. We'll definitely, if we are in need, we'll definitely talk about them later. But for now, just remember, like, just learn this and just get to know the idea of like how binary and decimal number system works with each other, so that we can work on the operators and operands. Now let's get back to our operators. So first we'll talk about the operators. Like the one important thing here is to keep in mind is that like when we go from top to bottom, the precedence will be decreased. Like I mean to say, if there is unary operator that is at the top and then there is arithmetic operator that is below the unary operator, the preference will be given to the unary operator. That means first we'll solve the unary operator, then we'll solve the arithmetic operator. And if we go below, like if there are arithmetic and let's say relational operator, so first arithmetic operator will be solved, then relational operator will be solved. So the preference of the like the operators goes from bottom, like from top to bottom. Like it will keep on decreasing. Okay, though we have to like we have certain conditions. Like if there are parentheses, so first we'll solve the parentheses, then we'll consider it as an entire equation. Like you'll get to know about this thing more in depth when we solve quotients, so that it will give us more clear idea. So let's talk about the unary operators themselves. So let me create a new page. Okay, unary operators. So unary operators are those that work on a single operand. Work on single operand. What does that mean is in general, let's say, suppose we do have two values, a equals 10 and then b equals 20. So in general, what we do like a plus b or a minus b. So there are two operands and then there is one operator. So this operator is a binary operator. But unary operator are only applied on the single operand, not on more than one operand. So now, okay, let's say there. Okay, let's talk about like the increment and decrement operator. Then we also talk about the other operand. So there are like, okay, let me write it. There is pre-increment, like there are pre, and then there is a post. Like you can see here, there is prefix and postfix. Like if we put the operator after the operand, then we'll say it's a post. And then if we put the operator before the operand, then we'll say it's a pre. And then there is increment, and then there is a decrement. So in pre, what is going to happen? Let's say if I do a plus plus, okay, it's a pre, so it should be plus plus a, right? Plus plus a, and then minus minus a. Pre-increment. Pre and increment. Increment means plus plus. This is increment operator. Like the plus plus is increment operator. INC. And the minus minus is decrement operator. What they do is that it will increase the value by 1. Increase by 1. It will decrease the value of whatever the variable or the value is by 1. Okay, so this is what increment and decrement operator do. And for the post, we'll say like a plus plus, and then for post decrement, it will say a minus minus. So what these are going to do the value, like it will give us like 11, and it will give us 9. It will give us again 11. But there is a difference between the pre and post. Like you might be thinking, if they both are giving the 11 value, then why even we are considering putting them before or after? But there is different. We'll talk about that difference. Okay, and then there is a 9. The difference is that, okay, let me erase the thing. It will be better. Okay, just let's erase this thing. Okay, so what it will do, let's suppose we do have variables c and d. Let's say c equals to plus plus a, and then d equals to B plus plus. Now, what's the difference is that, let's say if we print like SOPLN, that is system dot out printlen, let's say we said C colon, and then we wrap it inside the quotes, and then we give the value C, and then we also say SOPLN, and then we say D equals D. So now what's gonna print is that that will be interesting. Like it will print like C colon 11, but it will print like D colon 20. So now you must be thinking, why are we able to get this value 11 but this value as 20? Because we used both of the increment operators. The difference here is between the pre and the post. The pre says first the pre-increment, like the pre-values, whether it's a pre-increment or decrement. It will say first apply the operator. It will say first apply the operator, and then use it. But the post says first use the operator, like first use the variable and then apply the operator. Okay, so this is the difference between the pre and the post. Like here, whenever the operator is before, first we'll apply the operator and then we'll use the value of the variable. But if the operator is after the variable, then first we'll use the variable and then apply the operator. So both will give 11. But yeah, it will first use the value, it will first apply the operator and then use the value. It will first use the variable, then apply the operator. That's the difference. Let's demonstrate it in our VS Code. Let's see. Okay, let's delete all of this stuff from the last video. Let's see, we have variable int a, which is equals to 10, and then and then there is b, which is equals to 20, and then there is c, which is equals to, suppose for now, 0, and then there is also a d, which is also equals to 0. So now let's say c equals to plus plus a, and then we do also have like d equals to b plus plus. Now if you try to print this value, let me s out, let's say c colon, and then we will print the c here. Okay, there is some issue. Oh, there is a bar which shouldn't be there, and then we'll say s out. Oh, it's s out, my bad. If we do this, we say like d is something plus d. Now let's save it and check the result. So you can see like we are getting c equals 11, but we put the value of a is 10 and b is 20, but d is still 20. That means this is the difference between the pre and the post increment, and these are both increasing the value. That means we are using the increment operator itself. Okay, so I hope this works. Now let's talk about the other unary operators. One is their unnegation operator. That is, okay, there is this exclamation mark. So it just do like if the value, let's say, suppose if a is equals to true, about u a true. So if we put like if we do negative of a, it will give us the false. And vice versa. If it is false, then it will give us true. So negation just do this. Just we can say just if the bulb is closed, it will like switch on the bulb, and if the bulb is open like it is already switched on, then it will close. Whatever the situation of the current bulb is, it will negate it. Like if it's 0, it will turn it to 1. If it's 1, it will turn it back to 0. If it's true, it will go like it will make it false. If it's false, then it will make it true. The purpose of this negation is that. And there is also a tilde sign, like this sign. We can say this sign. So it not only work on the single digit. Let's suppose the value of the a is 10, right? A is 10. So in binary, we can write 10 as like 1010. So if we write like tilde of a, like if we say tilde of a, then it will give us not the negative of the a itself, but it will negate each and every bit. Like if it is like the a is 1010 in binary, it will give us 0101. 0101. So it will be like from 10, it will become 5. Suppose the value of b is, let's say, whatever, like let's say 7. So the value of b is 7, which is in turn something like this, 111. So if we put the negation of this tilde sign in front of b, it will give us like 000. So now the new value will be 0. So this is how this tilde work, and these both are like unary operators, like there is a difference. There is a slight difference. Okay, now let's okay, we'll talk about this thing in more detail when we are talking other. Okay, so this is how things are working. Unary operator. So now let's talk about the arithmetic operators, though we already know what arithmetic operators are. So I'm gonna just generally tell about, like in the previous video also I've talked about the arithmetic operators, I guess, but yeah, let me tell about the arithmetic operators themselves in more details. So we already know, like, if okay, let me keep on copying these numbers, like a equals 10 and then b equals 20, something like that. So if I say a plus b, we all already know like the, so this is a binary acting as a binary like operator here. So let me remove this. So it will give us like 30. If we do like a minus b, it will give us like minus 10. And then if we do a times b, that is a star b, then it will give us like 200. And then if we do b by a, then it will give us 2, right? But there is one more. There is called modulo. And remember, always remember, if it is like above in the table, if it is above some operators, like the multiplication operators are above addition and subtracting, so they will be evaluated first. After that, these addition operators will work. So remember, everything that is at the top will be operated, like will be resolved first, then the things that are at the bottom will be resolved. Okay. So now let's talk about the modulo operator itself. Like, but let's say if we write b modulo a, it will give, you know what, 0. Because this is called, let me write it with the other color. This is called a remainder, or the modulo is remainder operator. So it will give us the remainder. Okay, let me do the practice of this. Okay, let's say a number is, let's say 30 modulo 4. So what it's gonna give? Okay, let me demonstrate it. If the number is 30, it will always give us the remainder. We try divided by 4. So if we say like 7 times 4 is 28, so the remainder is 2. So it will give us 2. Let's do 9 modulo 2. So it will give us 1. Let's do 10 modulo 5. It will again give us 0. So this is remainder operator. Whenever we have to calculate the remainder, we'll use this modulo operator. This is different from division. Like if you put the division here, like if you have to calculate division, like 30 divide by 4, it will give us 7. It won't tell us about the remainder itself. It will only tell us about the quotient. But if we want the remainder, we'll use this modulo operator. Okay, so this is all about the arithmetic operators. In general, we already know about this. Is very simple maths. And then there is a shift operator. Okay, now let's talk about the shift operator. So, okay, there are two type of shift operators. Shift operators. Let me write. Shift operators. Okay, then you can see like okay, let's say there is a number. Okay, let's say we take a number. Josie, my bad. The number is let's say 11. So in binary we write it as like 1 0 1 1. Most probably this is 8 to 10 11. Okay, so this is in binary. Let me write it base as a base 10. So what shift operator do? This is let's say left shift, and then there is left shift, and then there is also a right shift. So let's say if we there is a number. Okay, a is equals to 11. So if we say a and then left shift and then 1, what does this 1 mean here is that we have to do apply 1 left shift. Okay, what does this mean is that because a in binary is like this 1 0 1 1, so we'll apply a left shift 1 times. That means we'll move all of these value 1 times towards the left, and then we'll bring a new value that is 0 at this place. So it will become like 0 1 1 1. So from 7 it will from 11 it will become 7. But if we suppose apply a right shift 1 time, so it will like from 1 0 1 1. Okay, this, just remember, this 0 is, we bring it from infinity. So suppose there are all the zeros here and here. So whenever we shift, this value go to infinity, and then we can bring a 1 more 0 from the infinity, like from nowhere. Okay, so if we apply like the right shift, it will become like 0 1 0 1. So it'll become like more of like it is 4 1 5. Okay, so this is how the left and right work. But yeah, let's say instead of like shifting it one time, let's say we do it multiple times. Let's say a left shift two or three times. Let's say two times. So what is going to happen? It is like 1011. So it will not shift every digit one time, but it will shift every digit two times. Like so, this one will come at this place. This one will come at this place, and then two new zeros will come. So it will become like 1100. That is in terms of like 8 and then 4. That is 12 in decimal, right? So this is how like shift operator works in general. Okay, there, and just remember their like their preference is below the arithmetic operators. Now there are relational operators. So let's talk about there is comparison and then there is equality as well. Okay, let's talk about the relational operators in themselves. So relational operators are let me see like if there are like less than equals to, greater than equals to, equal not to, equals to. Okay, there are. This is a sort of like let's say a and b again. Let's take our continuing with our variables. That is a equals 10, and then there is b equals to 20. Okay, if I say this a and b, this is like a is less than b. That means it is this will give us true, like true, because actually a is less than b. And then there is this is called relational operators, less than operator, less than. And then, I mean, we already know about these concepts. Then there is a greater than operator, which will evaluate to false because A is not greater than B. And then there is also A is less than equals to B. This is also always also like give us true value because A is less than. So we can compare like let's say there is some value. Let's say the value of A is 20. So this will give us false in that case. If we make if the value of the a 20, this will give us false because a is not less than b, right? So it will evaluate it false. But in this case, it will still be true because a is either less than, or we can say it is like it's telling us like if a is less than or it is equals to b. So it will evaluate to true. Okay. And then there is also a is greater than equals to b. But in this case, a is, if we don't consider this case, let me erase this case so that we can focus on our. Okay. So in this case, let's say, but in this case, like if we say a is greater than equals to, because a is neither equals to nor greater than b, so it will always like result in false. And then there are also equals to equals to. If I say like a equals to b, that means we are actually single equals to is called like if we say a equals to b, it is assignment operator. It will assign the value 20, like whatever the value in b is there, to the a. In this case, it will become like a equals to 20 itself. So this is like assignment operator. So if this is assignment operator, that's why we use double equals to as a comparison operator. So this is comparison. So if we do this, like a equals to, it will result in false because a is not equals to b because a is 10 and b, sorry. And then there is also a not, like if a, we can say also this, like a not equals to b. Then this will result in true because a is actually not equal to b. So in the general, I guess these are sort of like a relational operator. Then there are like bitwise operator. Before talking about bitwise, let me talk about the logical operators first. Then we'll talk about the bitwise operators themselves. Okay. Let's go here and choose our pen. So then we are going to talk about the logical operators. Logical operators. Okay. So these are like logical and logical or, and then there is all logical not, what we have already discussed here, but I'm going to tell it again here. So there is logical and first and okay, yeah. There is logical and we write it as like A and D all in caps, and then there is logical or again in caps, and then there is logical not. So what it will do is that if I talk about like there is a number or there is a number, if say suppose there is some value true and true, it will result in true. In all other cases, like if there is like okay, let me draw a table. Like let's say there are some table, let's say A and then B, and then it is sort of like true, true, false, and then false, and then this is like true, false, true, false. we'll write the okay. Let me draw it. Okay, we'll write the or like let's say and here, and then or here. You'll understand it better. So and is saying that like it is going to be true only and only if both the values are true. In all other cases, even if one value is false, it will result in false. So if we say two and two, the and will give us true, but the all or also will give us true. And or says that if it is only false and or like sorry false or false, then only in that case only it will result in false. In every other case, if there is even one single shoe, it will result in true. So now let's talk about this. Okay, if we say like true and false, in the AND case, because there is one false, it will result in false. Because in AND case, there should be always all the truths to evaluate the true value, else it's gonna result always false. But in the OR case, because there is one true, will always result in true. Now in this case again, there is like false and true. So and will result because one false, so and will result in false. But all will result in true because there is one true. But in this case, because both are false, it will result in false. And then in this case, even or has to result in false because there are all is false. There is not even a single true. If there is even a single true, it will result in true. So this is how and or works. And the not we have already talked about like if it's true. So like if A is true, you can say like if A is true, then the like negative of A is going to be false itself, and the vice versa. If the A is false, then the negative of A is going to be true itself. So this is all about the logical operators. Now let's talk about the bitwise operators themselves. Mhm. Okay, now we're going to talk about bitwise operators. So there are AND, like bitwise AND, bitwise XOR, and then bitwise OR. Okay. The difference, remember the difference. Like this is logical AND, this is bitwise AND, okay? We can write it as like it will result in like AND. So it works on the bits. The difference is that, and then there is XOR. It is XOR. I'm going to tell it what it is. Then there is OR. So the concept of and or is same. Like if both the values are true, only then it's gonna result in true. And but the thing is that like let's suppose A is okay. Let me choose the green for always choose green. A is 10. B is let's say in this case not the 20 but the 12. Okay, let's we can do 20 as well. So in binary we can write the A as like 1 0 1 0, but in decimal we have to write 1 1 0 0. For sorry, in binary we have to write the B is B like this. Look, this is A in binary, this is B in binary. Okay, so if we apply, let's say first we apply and okay, let me change the color. First we will apply and then we'll apply or. So if we say we have to calculate the and, so it will like this binary bitwise operator, this bitwise and will work something like this. Like it will say like, okay, if it's a 0 0, then it will give us 0 because both are 0, both are false. 0 1, it's again give 0. 1 0 1, it will give 0. 1 1, it will give 1. Okay, now let's talk about the or itself. So it's gonna be like 0 0 is always gonna be 0. 1 0 is gonna be 1. 1 0 is like 0 1 is gonna be 1, and then 1 1 is gonna be 1 again. So it is like decimal equivalent to 8, and then it is this decimal equivalent to 8 for 10 and then to 12. So this is how it will evaluate the or and the and, like bitwise or the bitwise and as a result. Like let's say C equals to let's say A and then and B, and D equals to A or B. So it will give us the value 8 and it will give us the value 12. Okay, now let's talk about the XOR itself. So XOR is something like, okay, let's say A XOR B. So it will give us the value if the, okay, XOR, like let me first create the table of XOR. So this is XOR, this is A, and then this is B. So 0 1 and then, okay, 0 1 0 1, let's say do here, and then 0 0 1 1. So this is XOR. If both of the values are the same, it's going to result in false. If the values are different, it's going to result in true. So in this case, it will give us like, okay, it will give us 0 0 like that. Because you see here, both the values are false, it will give us 0. Values are different, it will give us 1. Values are different, it will give us 1. Values are same, it will give us 0. So this is how XOR works. Like let me create it as well, like for the XOR as well, like XOR. So let me scroll up. So 0, 0 is gonna be because both are same, it's gonna be 0. 0, 1 is gonna 1, 1 and then 0. So the XOR value will be something like it's a 4 and 2, so it's a 6. So if I say like E equals to A XOR B, so it will evaluate to 6. Okay, so this is how like bitwise operator works. There is a difference you see there. It will just work on high level. Like, if it's a true or false, it will give us true or false accordingly. But bitwise operator works on each bit and give us some value that is non-zero. It is giving us either a 1 or 0 value, but it is giving us some other value, which is not a 0 1 always. Like it could be 0 and 1, but it might be something else as well. Okay, now let's move to our next operators that are ternary operators. So ternary operator is a question mark and a colon. Now let's talk about this. Okay, because it is generally used to ternary. It is generally used to create a ternary equations. Let's say again our value of a is 10, and then okay, b is 20. So now how this works is that suppose we have to say like c equals to a less than b. Okay, sorry, a less than b question mark and then this colon, and then we can say is greater, and then we will give it. Oh, my bad, it didn't work like that. Okay, here's only a question mark, and then after that only we can put this column is smaller. Okay, now suppose we have to say okay, okay, in this case we have created. So this is ternary. Like you have seen there in the ternary operator, there is a written a question mark and colon. So this is like okay. Let me use it. It's okay. Like this itself is this question mark, and then this colon is this thing. What's going on here is that we will assign a value to a c based on this thing. We are saying is if this equation is true, then we'll say b is greater than a. But if this equation is false, then we'll say b is smaller than 2. So in this case, what's going to happen? Because b is greater, so it will evaluate, this value will evaluate to true, and then this is greater will be assigned to this c. So now c, if we print c, it will be is greater. Like b is greater than a. Now let's suppose we remove, like we instead of using 20 as a value, we use the value of b as 5. So this equation will become, in that case, this equation will become false. So this is the equation. This is the question we are asking. Like if this is true or false. If it is true, then it will like use the first value. But if it is false, it will use the value that is after the semicolon. So it is something like that. It is equation EQU, and then we'll ask the question. If the value is true, it will use this value, true value. But if the value is false, it will use the false value. So this is the combination of ternary, like this is generally used to create ternary equations itself. This is all about the ternary. Like okay, let's do one more example. Let's say d equals to. Okay, let me create in this case, a is greater than equals to b, and then we'll add question, and then we'll say because in this case, if this is true, then we'll say a is greater, a is large, else a is small. So now let's see, like we are using this value or whatever. So a is 10, b is let's say 5. So it will say, okay, a is greater than or equals to b. This condition holds true. That means what is the value of d? So d will be evaluated as a is large. So we can take more examples, but this is the general idea of like how ternary operator works. Now let's move to our last operator that are assignment operators. There are a lot. Like in general, this is okay. We have already talked about the assignment operators themselves, but let's do it again. Assignment operators. So we have already seen, like we already seen this thing, like a equals to 10. That means we are assigning value 10 to this a. But there are more. Like there are like we can say a. Okay, let's say there is a b as well. B equals to 20. So if we can also say like a plus equals to 10. What does this mean? Is that this is equivalent to this thing. We are saying a equals to a plus b by plus 10. It is similar like that. So plus equals to means that we are using, like, instead of like short, it is sort of like shorthand. So instead of doing this thing, a equals to a plus, whenever we have to add some value to the operator that is going to have the value, we can also use this thing. Like we can also say like a minus equals, oh sorry, a minus equals to b. That means it is equivalent to, we are saying a equals to a minus b. It is, these two are same. And then we are also having like a multiply equals to b, or a divide equals to b. We can see all of these operators here, like plus, minus, multiply, divide, modulo, amp, like bitwise and, bitwise XOR, bitwise OR, and then left shift, right shift. We can do all of these values with this a. So it will be resulting in like this. So these are sort of like different assigning operators. So I hope you understand all of the operators well. But if there is any question, you can definitely ask me in the comment section. And thanks for watching.